which this is the best you can do. Binary because it splits it and splits it. I demonstrated that in the telephone program. Split it once and then split it again. And so if I've got eight things to resolve, I can find it in three comparisons. It just gets better as you get more and more things to search. As you get, suppose I have 1 billion pages to search. If I could do it, if I could. So for things like the if logic, I'll tend
testing now. Testing. Okay. Okay, we got the audio up. Gee whiz. Okay, go ahead, and I'm gonna mute your.
Pro, and removing the physical home button will allow more of the screen to go to the edges, like the iPhone 10. An OLED screen would not only drive up cost significantly.
Okay, hang on. Okay, now I think we've got it. Okay, good. I've got, I have audio now. Don't want to do that again. Okay, lost a few minutes there. But this is the recording for ITSC 2347. I pointed out that the first one, you have these files. The first one is poor because there are no else's. It keeps going through it. This is a little bit better because I've added in the else's. This is better yet because I took the last one off. And this was pretty good because this one, the second if, had a comparison. I no longer had to consider A. It was between B and C. So I could drop that one out. and I can get it now. I'm in 1, 2, 3 comparisons. This is the best. This one's a little longer actually in terms of typing it, but the outcome is determined in 2 sets. Now, here's the one I was talking about. We were discussing this one, and we discussed that what happens if this first one is false. The first one is false and it stops evaluating is called short circuit Boolean evaluation. And that's something you always have to ask the about your language. Do you do short circuit Boolean evaluation? Yes or no? And for example, C and Java and those languages definitely do. Visual Basic does not unless you do something special. For example, and I think you say and also instead of just and that's the flag that you have to, that's supposed to check one of them. If it's true, check the other one, but if it's false, just stop. It's an and. Like similarly with an or, if the first one is true, I can stop because if an or condition will be true. We cannot guarantee that with a TSQL. So if my second condition on the and is something that's going to cause me to die, for example, if A is 0, now I'm dividing by 0 when I try to do 1 over 0. And if I try to do that, I'm going to get an error condition. Okay. So what I should do with that is break it down into 2 ifs. So if this will force it to say if A is not equal to 0, then if that's true, then go to the next one, else do nothing. So I would accomplish the same thing. Go ahead.
With the AND operator, will the computer evaluate both conditions, or will it stop at the first?
That's the question we're looking at right now. If it stops after if the first one is false, and if it stops, that is called short circuiting. Lots of time, most of the time it'll go left to right. I'm pretty sure, well, okay, left to right is the logical precedence. The computers are getting so powerful nowadays that I have multiple registers available to me. So I'll just do them all at the same time. Right? I'll start that division at the same time I'm evaluating the first one. So I just set them up, and the compiler, the runtime support system can just set them into 2 different registers and start everything at once and just see what you get at the end, figure it out later. And so that's a big hit. So short circuit Boolean evaluation is slower than if I don't have to do that. The problem with it, but if I need to check the first one, then check the second one, I'll have to break it into 2 if statements. So that's what this is essentially an and. If this and this, but don't do this one if this one's false. Similarly, or if this one is true, it should short circuit. If this one is true, we should sort. There's something wrong with this.
So fundamentally, are you saying that
I should say.
Using the and or operator, you would like us to use nested?
I didn't say that. Okay, just because you're using the and or doesn't put you in a dangerous position. The dangerous position we've got here is the fact that this one, if the first argument to that relational operator is false, in other words, A is equal to 0, this one is going to blow up and give me an error. I don't want a division by zero error because I don't like seeing red letters all over my runtime screen.
Well, that goes back to the first question that I asked.
Mm-hmm.
Would the computer evaluate the first condition?
Okay, and that's what I'm talking about here. You can't guarantee that it will do it that way. I'm going to show you the actual documentation here in just a second. You can't guarantee that you're going to punch out. I call it punch out, short circuit. In other words, it found that the first of an and was false. It says there's no point in looking at. I know what it is. It's false. So there's no point in looking at the second one. You can't guarantee that it won't do them both at the same time. Okay, in that case, you would hit an error. So you break it into two when the second one is going to kill you. I made a little change to this one. I said greater than or equal to 1. I forgot to flip that around. So the second one is or. So that one, and the or, I have to do it twice. So if this one's true, set B to 1. If it's false, then I look at the other one, and then I set B to 1. So that's how you short circuit an or, also called a disjunction. The or is a disjunction, and is conjunction, or is disjunction. We can't count on it. Now here is the from the formal definition, and these things are a cure for insomnia. If you go in and read them, they will drive you nuts. Where the precedence is not determined by essentially the parentheses or anything else. Effective evaluation of expressions is generally performed from left to right. However, it is implementation dependent, whether they're actually done that way or not. Particularly when operands or operators might cause conditions, errors, in other words. So, you can't guarantee what it's going to do. The name of the game is be ready for it to do either way. If all I'm doing is something like this, it really doesn't matter. Doesn't matter which one it does first. I don't care. Just do them both. Do them both at the same time. It doesn't bother me a bit what it does. Okay. If one of them is protecting the other one, you'll run into that in C when you're using pointers. For example, have you guys ever used pointers in C? A pointer is a memory address, and if you go chasing a memory address that hasn't been assigned to you, you die a horrible death. Your code you just blue screen. Or I guess we don't blue screen anymore, but used to be you had to reboot the machine. So you would check to see, is this pointer assigned to me? Then you follow it. So you say, if this pointer is assigned, and follow it and get what you want to test out there. But in C, you can count on short circuit evaluation. In Java, you can count on short circuit evaluation. Other languages, you can count on it. You just have to know that about your language. This one, you cannot count on it. Enough said on that.
So wait, when you say implementation dependent, are you talking about the EDMS?
That means you can't count on it in this language, in TSQL. When you say and, in SQL proper, pure SQL, when you say and, it usually doesn't matter because there's very little you can say in pure SQL that's going to cause a runtime error. You don't do much of that. It just doesn't come up real often. In the language, sometimes it does. Don't count on it unless you know for sure that it short circuits. And that's enough of that. I did send you out the Did you get the zip files? The zip file? Okay. Need to make sure. Am I still? Yes, I'm still recording. Let's see. Where am I? On desktop. Okay, sequences. Sequences are covered in the text, and we've talked about using fields that are called identity in SQL Server. In Access, for example, they're called auto number, and most databases don't even, well, Oracle at least, I don't believe, last time I used Oracle, they didn't even have one. So database people don't tend to like auto numbers and identity unless you're just doing something that's quick and dirty. In that case, it's kind of handy to have one when you just say identity and you're done with it. The problem with identity is that you can't insert something that you want to in there, and it gives you a little bit of it ties you up a little bit. So all you can do is take that identity, take what it gives you. If you override it, then you can't turn it back on again. Okay, so first line, always specify here's the text pages that this is covered on, 356 through 359. It's not a great treatment of it. At the first line is always the database all creates sequences. When do we use go? We use go when we want, everything to go away. Go means go, it all goes away. Everything you've created in the program in terms of variables, cursors, anything, when you hit that go statement, they all go goodbye. So no more variables are defined. But if you create something in the database, a database object, it is usually bracketed by a go. Go. So even though you can get away with creating a table without it, it is good if you're going to create a table, bracket it with a go statement. Go before it and go after it. So this is a sequence. If you look on the page 356, there's about 8 or 10 different things you can set about that sequence. These are the ones that I usually set. So create sequence, and then you give it a name. The name has to be unique in the database. Okay. I typically begin mine with SEQ so that as I see its name, I know it is a sequence. Okay. Notice that I do that a lot. I prepend something to my identifiers that tells me what the heck this thing is. Then it's got the name stuck to it. Okay, as int, if I just say create sequence and give it a name, I get big int. I think I made a note there that I said something wrong. I called it a long int. It's long int in C and Java. Here we call it a big int. It is an 8-byte integer, big one. We can start with any number. So I say, let's start with 100. Okay, I just did that. I usually start with 1. I don't usually set that. I usually just create the sequence and I give it a type. Okay, so I'm starting with 100. Increment by 5. The default is 1. Okay. Now, the next one is kind of interesting, the cache. How many numbers does it cache? Okay, think of a roll of numbers at the butcher shop. And it says, take a number for service, or at the VA or something. So you go up there and you take a number so nobody can get in line ahead of you. And then they call, now serving 27. And that's great, I'm 76. So as they call your number, okay, but whatever, let's go back to taking that number. No two people will get the same number. If two people reach at the same time, one of them is going to get in ahead of the other one. And they'll get the number, then you get the next one. What this does, it says you don't just take a number. Cache 10 says you take 10 numbers. numbers. Then the next time you want to take a number, you don't have to go back up there. You just take it from your pocket. So you take 10 numbers, put them in your pocket. And now the next time you use it, and this is real handy, it speeds you up a lot because you don't have to go to the database system to take the number. You've got it there in your program, and you just use the numbers from your program. You're typically using them for a primary key because the two will not ever get the same numbers. So I'll take let's see, start with 100. I'm going to take number 100, 101, 102, 100 through 109. Next person will get 110. Okay, I just keep those numbers. If I go away, I don't know what happens if you do a go. They might go away. Your cache might clear if you do a go. But if you don't use them, you lose them, kind of thing. Okay, it never goes back and gives them to you again. So if it's important to you to keep the numbers perfectly ordered, then you should probably use an identity. You can still, if you delete a record, you'll never get that number back. Question?
So the numbers in sequence are
Yes, there are numbers in a sequence are unique. Now, they do not have to be ordered. If you use the flag no order, you'll get a seemingly random set of numbers, but they will be ordered. That's the default. If you say no order, you'll just get some integer and you'll never get that integer again. I don't know how they do that. That'd be a tough thing to do. Generating a random integer is fairly easy. Generating a random integer, a sequence of random integers where no two can be unique. I'm going to have to look up that algorithm and see how you do that. Kind of like calling bingo. You want a random, but you can't use it again. So this one's going to start like that. Pretty straightforward. Let's demonstrate this. Okay. Sequence for the phone PK is not null. Drop the sequence. Okay, you drop a sequence it's just like dropping a table. Here I create the sequence SEQ phone PK. Start with 100, increment by 5, cache 10. Is that the same thing I did up here? Yeah. So I dropped it and then redid it. I create the table. My primary key is CHID. Here. Notice I did not make it an identity. So when I insert them in there, this is how I insert. This is how I access the next value. This says, take a number, essentially. And so this one, when I do this one, since I'm caching 10, I get 100, 105, 110, because I'm incrementing by 5. So this gives me 100, 5, 10, 15, 20, 25, 30, 35, 40, and so on, right? And I took 10 numbers. So I have 10 of them cached in my program. Now, other people, the good thing about this is that other people can use this sequence. So if I have multiple people updating the same table, I should use a sequence for the primary key. It's better than an identity. And the way I put it in there is I just take the next value. So I explain to them that's how you have to put it in. That way you are guaranteed that if you're inserting into my table and I'm inserting in my table and you're inserting into my table, we won't ever collide with our primary keys. So that's the purpose of this sequence. And what am I doing here? This is just the same. All this does is updates. Notice some people, I think I made a comment on yours, Mary, wasn't it, where you were updating it using the two using the two plays, P and the player 1 and player 2. Was that you?
Yeah, well, I think what you're saying with me is that I wasn't taking into account duplicate plays.
Right. And now, if you had duplicate plays, you'd have a duplicate winner.
Well, I had like, that say,
So player 1 chose rock, player 2 chose paper. Player 2's the winner. If player 2 chose rock and paper, player 1 and 2 chose those same plays elsewhere, player 2 is still going to be the winner. So it doesn't give you wrong data. You just update, you may update more than one row. No. You should be using the primary key. So this uses the primary key. So this one,
yeah, I wasn't using the plain.
yeah, notice that this one's a little bit different in that the cursor returns the primary key. So as it's reading, I get the primary key, stick it into a variable.
That's what I was doing.
Now, I've just, I didn't take off any points. So when if I run it, it'll work. You can, I'm gonna let you run it. I just said that. If I test it, I'm gonna create this. So here I'm gonna have to use SW Smith. I don't think I have a Scratch database here, do I? Yeah, I do. I have Scratch. Okay, so I could use Scratch. I do that when I'm just playing around, goofing around. So I need to execute this. Execute. I'm so glad. And let's create the sequence. Execute him. He's successful. Testing. I think these will stay. So I got those guys, and now let's see what they are. I'm expecting them to be 100 and 105. Let's see if this will execute. Nope, it won't let me execute it like that. I have to execute them all at once. Now the phone sequence, I think, will stay around. So 105. And I didn't put anything in 102. If I execute it again, 110, 15, 20, 25. So it's going to keep going like that. Sometimes I will step by 5, just in case I want to go in and insert a record in there, some in between them, so I know that I can take anything that doesn't end in 5 or 0, and I can put it into the database. Sometimes I want to do that. Okay, most of them give you a way to get the current value, to go in there and ask, well, don't give me a number, but what is the number that I would get if what was the last number you gave out? Okay, so you take a number, everybody's taking numbers, and I want to know what was the last number that was given out. In other words, what will I get? Because I can do the math and figure it out. So if I'm incrementing by 1, I say, what's the last number? Well, if it was 99, that means I'm going to get 100. Most of them give you a way to do that that's easy. I don't do it very often. In Oracle, for example, you would just use current value for the phone signal. Not exactly like this. You don't use these in Oracle, but it's just current value. Actually, SEQ phone PK dot current value in Oracle, but you don't really care about that. But not in SQL Server. Bright side is we don't do it very often. This is the way it's done. Select, it's still current value. It's kind of tedious and cumbersome, and I'm not going to remember that, and I won't ask you that on a test, but that's how you get it. And I thought I'd...
That's within TC core, that current underscore value.
Right, this is TSQL. So if I execute this, so this is going to be going to my int 2. So the second one, I don't know what my int 1 is, probably nothing. Well, okay, I got to declare them. So I got to execute all the way down to there. But anyway, this will give me the current value. Okay. Now, we'll talk a little bit about granting. In order for somebody else to use my sequence, I have to grant them update, because think of it like a table where it just has one column, maybe two, current value and next value. So I have, as you take a number from it, you update that roll, you change it. So you have to have update privileges on that counter. So if I grant update on phone sequence to the public, then I can, anybody can do it.
So you're not just reading it, you're updating it?
Right, it changes it.
How does reading it change it?
Well, if I take a number, I get 100, and now the next number that it's going to give out has changed to 105. You take a number, you change the next number that it's going to give out to 110. So you've changed the state of that counter. So you have to have update. If I grant update on it to public, it was successful. Okay, now I'm going to go let's see.
So like if you thought of the analogy of what you were talking about, like take a number at, the deli, that number that's shown is actually changing, right? So that's...
Yes. Mm-hmm.
Okay.
So that's why you're updating it.
Okay.
Let me see what user I've got here. I don't have a public user. I could, I'm going to go ahead and I need to make one. We're going to make one for this class, so we're going to have multiple users. And so another user would now be able to take a number from any user that is connected to the database would be able to say, that was a user of my database would be able to say, use that database and take a number by next value for DBO database owner, because I'm the database owner and I gave him the right to and this is why that this name has to be unique in the database, because other people may or may not be in your database. So that name has to be unique. So some database owner, and then it finds that name and gives him the next number. Questions? So the beauty of this is that we, and I think on the, that I asked, I don't recall whether I haven't written all of the assignments for this module yet. I want to do one for functions. If you have a primary key, I'm going to ask you to use a sequence. That's how you do it. And you have this file. Questions? Okay, anybody? I'm going to unmute. Anybody want to? Okay. Unless you've muted yourself, anybody want to ask a question? Anybody? Okay. I got my headphones on now. Anybody? Okay. Yeah, it's okay. I'm gonna mute. Testing. Okay. Okay, user-defined procedures. This is where the rubber meets the road. So now we're getting into the programming. Up until now, we've been doing batch programming. Batch programming is, well, it's a fussy, cranky, verbose language, meaning it's long-winded. You end up doing a whole lot of typing in it. You typically have long identifiers, and then you have to type that annoying @ sign in front of something, and you have to say set when you're assigning variables. And it is not my favorite language to type. It just isn't. I'm a C programmer. I do not care a whole lot for this syntax. But if you can't have the language you love the language you have. And so I don't really care one way or the other about it, but I wouldn't choose this one, let's put it that way. Up until now, we've been doing batch programming. It's like a batch file in DOS is a series of DOS commands strung together, and you can put if, then, else in there. You put if, what is it? If go to, I think it is. But yeah, I can create if then else's, and I can create while loops and for loops and post-test loops in DOS programming language by how I put the ifs and go tos. The beauty, though, of a programming language lies in its ability to compile a program and store that compiled program in the database. If you have a compiled program, it will run circles around a batch program. Maybe not any batch program in any compiled program, but it's going to execute much, much faster because it doesn't have to read each line. It's an executable file that's stored in the database. So it's way, way ahead of batch programming. Now, a procedure, what languages do we have here? Donna, what language have you studied before? C, Java. Okay. Others? Java and C. Okay. Java. Okay. Most of us have done some Java and some Java. Well, you done C and Java. C and Java are in some ways pretty close. They look like they're pretty close. Under the hood, they're really different animals. But the way you do it's the same thing. And the way you drive any car is pretty much the same as the way you drive any other car. I mean, with respect to the steering wheel, the pedals and all that stuff. They might look a little bit different. So for example, in C, a procedure would be something like this. It's a void function. It's a function that doesn't return a value. Well, can you have a function that doesn't return a value? And I'll always get into arguments with other C programmers. And no, C doesn't have a procedure. In C, it's a void function. And I say, nonsense, that's a procedure. A procedure does things for us. So this procedure is called telephone. And this procedure takes two parameters. It takes a character that is an input parameter. The first parameter is an input parameter. In C, we always pass parameters by position. So the first parameter has to be a character. Now, this could be just the literal character, quote, C, quote, X quote, right? Or it could be a variable. This is an input parameter. When this function is called, when this procedure is called, it will copy the value of the parameter, the actual parameter. Down here, my char is H. It will copy the value of this first actual parameter, and it will initialize the first formal parameter to that value. I will use those words a lot. Formal parameters are the ones in the function, in the procedural definition. Actual parameters are where you call it. Okay. Now this second parameter is an output parameter. An output parameter is different. I have to do something special to make it an output parameter. In C, I lead it with the ampersand. You can have a space. It's okay if you have a space here, but I do something special to it, and I say, this puppy is different. This one can come in and be changed and go out. If I tried to change the first one, it's not going to do anything. But if I change the second one, it will reflect back to the main program. What happens with this is that when I execute it and I pass it the actual parameter must be a variable, because I can't change the character A. So this would be legal. That would be a legal call to the procedure telephone. I can pass it just an H. Why? I can make a copy of that just fine. It's an input parameter. I make a copy for input parameters. If I tried to put a literal there, it wouldn't work, because I can't change the literal value to or whatever. Okay. So what happens is that this becomes another name for this. You pass its memory address. This is called a pass by reference. The first one is called a pass by value. Second one is called pass by reference. This should be review, right? Seen this stuff before. Okay. We're going to see the same stuff come around here. Same stuff, same old, same old. It's just the parentheses are a little different. And okay. I don't know what this is. Okay. Oh, yeah. I want to talk about these guys right here. You'll see these in lots of programs. I've commented them out. Set ANSI nulls on. Have I talked about that yet? Set ANSI nulls on. When you put that in there, if you compare null, if null is equal to null, it will return true. It will allow you to compare something to nothing, and it will return false if it's equal. I don't know what it does. I think there's some. I think null is less than everything. I never use it. Right? You can still use if something is null. You shouldn't compare nulls. But if you have ANSI null set on, then the database will compare null to null and return true, or null to something that's not null and will return false. Are they equal? Is your car the same age as my car if neither of us have cars? That doesn't make any sense to ask that. So I never turn ANSI nulls on. Set quoted identifier on. That says that you can have identifiers that have spaces in them if if you have it inside of square brackets, and in SQL will allow it if it's inside of double quotes. That's the only place you'll ever use double quotes. Terrible idea. Terrible idea. Sometimes you'll see these. Just thought I'd mention what they were. ANSI nulls, set quoted identifier on. Let's see, the other one is no count. Set no count on. Sometimes you'll do this if you want to. If you want to suppress those little messages from the server about 1 row affected, 3 rows affected. If you want to suppress that, you set no count to on. Seems like you should set count off, but set no count on. Oh, whatever. You'll see that one used sometime. It's a popular one. Okay. I will always say create or alter procedure. I see you're saying drop procedure if exists. Okay, there are multiple ways to do this. This is the way I'm going to treat it. I'm going to say, now you can drop the procedure, yes. So you can say if, you can do it just like a table. So you can drop the procedure just like we dropped the table, only it's drop procedure instead of drop. And so if the object ID is not null, drop the procedure and give it the procedure name, and that's fine. But this one with procedures and with programs, you have create or alter. And that's handy because you don't have to write that drop routine in there. It'll take care of it for you. Then when you're done with it, just drop it. Okay. So I always teach it as create or alter. If you say create and it already exists, you get an error. If you say alter and it doesn't exist, you get an error. If you say create or alter, it saves you a lot of trouble. And the name of this one is telephone. You can also say create or alter PROC. You don't have to type out procedure. You can call it PROC. I usually spell it out. Then following that is the parameters. Now, I believe, did I see that you had yours in parentheses on the procedure? Your parameters? I was wondering, most of the time you will find them in parentheses. No, it doesn't like that. Okay, so you don't use parentheses here. It's kind of strange because most of the time the formal parameters are in parentheses. When we get to the functions, the formal parameters are going to be in parentheses. Okay, well, they're not on procedures. So this syntax is a little bit squirrely here. You have to keep going back to it. That's okay, because when we get to the test, I'm going to let you use your book and your notes. So name of the game isn't to try to memorize it, it's try to remember where to find it and know the right questions to ask and when you're trying to look something up.
You can do the parentheses, but it's before the A.
Oh, okay. So it's pointed out that I can have parentheses and here. Okay. Okay, I like that better because I'm expecting parentheses to go there. That set of parentheses I just put in are optional. Okay, I don't think the book uses them. CH is an input parameter because I didn't do anything special to it. Remember back when I was talking about C, if I just gave it a name up here, remember? If I just said it's a char, it's an input parameter. If I don't say anything special about it here, if I just say it's a char 1, it's an input parameter. It's a copy of the actual parameter. Makes a copy. When it finishes, it throws away the copy. I don't know whether you can change it or not. It doesn't make much sense to change it. Some languages will let you change it. C will let you change it in your procedure. The changes are just thrown away, so it's usually an error. So because of that, most languages will stop you. Java will stop you. Okay, this one I'm doing something special to. I say it's output. Okay, so usually the way it works is if you just declare the formal parameter and you just give it a name, give it a type, don't do anything else. It's an it's an input parameter. It's in only. It's called a value parameter. It's just a copy of the value. If you do something special to it and say this one's different, it becomes a pass by reference, then it's passed by a memory address. And that one has to be a variable when you actually call it. This one can be changed. It can bring information in, it can come in with a value, and it can go out with a value. In some languages, you have an input-only parameter and an output-only parameter, and then you have an in-out, input-output. I don't know why they do that. Okay. So I was just testing this one. When I printed the digit, I wanted to see if it came in with a value. Okay, so I just go down through this and I say, here, this is just the plain old logic. I throw an error there. I don't think I ever catch that error. Look at me. I threw an exception. Oh, okay. Okay, I throw the exception to the calling routine. The catch block doesn't have to be in here. So this guy's just going to throw an exception. It's going to abort the program. It's going to abort that stored procedure, and then the exception propagates up to the calling level. I wrote this a week or two ago. Okay, so here's where I start. This is the end. Now, all good. This is a create block. I'm creating something in here. So what am I doing? I'm creating the procedure telephone. Therefore, I believe it's going to force me. It's going to make me have a go block. I think that if I don't have the go block, I think it's going to give me a bunch of red lines on stuff because it has to be in its own program. So go. Anytime you have the word create, bracket it with goes. Creating a table, creating a sequence, creating a view, bracketed with goes. It's about time for us to have a break. I'm going to try to get on through this piece of it and take us to the finish up right here. Okay. In val, so I have one here called in val and out val. Notice that the names of my actual parameters do not have to match the names of the formal parameters. And I pass parameters by position, so this is in a try block. So if this bombs, it's going to get an error. If it's an invalid character, this one gets an error. And so execute telephone, in val, out val, and notice I have to tell it that this one is output. Not all languages make you tell it that in the calling routine when you call it. But here, if you call it, you have to say, yeah, that's an output parameter. Don't know what happens if you don't do that. I haven't tested everything about it. I'm kind of new to this language too. So I don't know what would happen if you didn't have that. I suspect it might pass it by value, might make a copy of it. So execute it, the catch. If we threw an exception, we never get here. So if we threw the exception, I think we should get here if we throw the exception. I'm not sure that's right. Okay, I got another one going on here. Here's the thing that I want to show. It is possible in this language to pass parameters by name. Now, notice that in this case, I switched their order. Okay, the first example up here, when I executed this one, I passed the parameters by position. So the input parameter had to be the first one. The output parameter was the second one. They're passed by position. In my opinion, or at least as far as I'm concerned, I think that passing by position is the way I would do it. But you might have a different opinion. It's okay. Okay. That also gives you the ability to pass the parameters by name, now notice that these two are reversed. But I say that CH is equal to inval and digit is equal to outval when I pass them. Okay, you can do it either way. The first one requires that you know what position they go in. The second one requires that you know the names. So I have to know something either way. Yeah, yeah. The order doesn't matter if you're passing by name, if you're passing by value, excuse me, if you're passing by position, the name of the formal parameter doesn't matter. You don't even have to know it. You just have to know its position. And usually when you read the documentation, it says the first parameter is, the second parameter is a char passed by value, excuse me, passed by reference, meaning it has to be a variable. So the first parameter is an input parameter passed by value. Second parameter is an output parameter passed by reference. So that means that when whatever you put in that second parameter position, you have to be aware it's probably going to get clobbered, whatever value it came in with. Okay. Yes.
Regarding you mentioned about the output. If you comment out the output, the procedure is still executed, but the output value won't be.
I suspected that probably.
No error.
I suspected what it would probably do would be it would make a copy and send it in as a copy. Yes. So if you don't say output, what you get is a value parameter, meaning you get a copy of that, of its value. So it can't change it unless you say output. And that's kind of what I thought it would do. I've seen other languages do that. Visual Basic, for example. Microsoft is famous for that. Okay. Questions?
So I saw where you
Declared what?
I saw you where you declared the variable digit and
Okay, the variable digit and the variable, the digit is not a variable. The variable we have is outval, and the variable we have is inval, and they are declared here. And by the way, it is legal to stack them up like that. Separate them by commas.
what are digits?
Okay, it's a good question. Okay, these guys are the actual parameters. So when I call it, let's go up to this one. When I call the routine here, I pass it actual parameters inval and outval. Okay, what happens is this is by position. The first actual parameter gets copied into the first formal parameter. The second actual parameter, the second formal parameter becomes another name for the second actual parameter. Changes made in the subroutine, when it sets digit up there in the subroutine, it changes the one in the main program. It changes the actual parameter in the main program. So this one is passed by position, the first one and the second one. So this one goes to the first one, second one goes to the second one by position. This one, they are passed by name. And here I say at CH is equal to inval. The variable name is inval. The formal parameter name is CH. I'm saying make CH get this value. And the parameter named digit gets that value and make it be output.
When you're talking about passing, what are you passing?
I'm passing in the case of CH or in the case of digit. In case of CH, I'm passing a copy of the variable inval. Makes a copy of it and passes it to the subroutine. That particular one is by name. No, passing by reference is when you say it's an output parameter. Output parameter is passed by reference. Passed by reference says it passes a memory address. Okay, when you see the word output, some languages will say it. Some languages will say by reference. When you see the word output, pass by reference, just think, bing, reference. Okay. When you pass by reference, you're passing the memory address. Pass by reference, if you make changes in the subroutine, they are reflected back. I think it's just about break time. Don't you? Okay, I'm going to pause the recording. Let me ask here, I'm going to unmute. Okay, you guys are unmuted unless you have chosen to mute yourselves. And if you want to ask a question, I have my headset on.
I'm good.
Okay. Okay, I'm going to pause the recording and we're going to take a break. And we're back after the break and we are recording again. Right now we just wrapped up the creating the procedure. Interesting thing, let's see. Nice thing is that when I create a procedure, take these earphones off. When I create a procedure, the procedure is created in the database. For example, if I execute this, just the create procedure, let me execute, just said success. It didn't do it. It didn't execute the procedure, it just created it. Where is it? It's in my database. I can go find it. For example, if I were to go, where is my Object Explorer? It's under View. There. So, for example, if I go into this and it's stored in, I think it's stored in Scratch. If I go into Programmability, Stored Procedures, did I store it there or did I store it in SW Smith? I should see it right there. Maybe since I didn't execute the use, maybe I stored it in SW Smith. There it is. So SW Smith is my default database. So unless I say to use something different, so I'm going to end up with two of them stored in there. So since I never executed the, delete it. So I should have said, now when I execute it, I should find it in Scratch. Yeah, you gotta, this guy doesn't always pick up real quickly. Sometimes you have to go all the way down and refresh. But whatever, it's over there. So where is it stored? It's in my data. It's in the Scratch database. So I can run it, but unlike C, where you usually declare the procedures, you usually write your excuse me, your procedures, and then afterwards you have main, begin main, or maybe main comes first. By convention, I think main is the first one you write in C, and then your procedures come under it. Similarly, sometimes it's different conventions for different programming languages, but basically your procedures and functions are defined in the same you are the way we teach it as they're defined in the same file. They don't have to be. So when you compile the code, you compile the procedures and everything together. Not so in database, because when you compile the subroutine, it saves it to the database, right? So I have access to that now. Anytime I'm on this database, I can use it. I don't think so here's H. Use. Character H corresponds to a 4. So it executed that procedure. And so when I say exec, I think I can say exec, I can also type out execute. Will do it. Most of the time I opt for the one that is less typing, because this language is brutal on typing, in my opinion. It isn't real. Questions? Anything else I need to cover here? By the way, when you have a value parameter, this is a test. This one should work. If I execute telephone and I just pass it an A, I should get that. I'm going to have to go up and I'm going to have to execute all the way down, because I won't have out val unless I. So there's the 2. So if I can pass to a value parameter, to an input parameter, it is legal just to pass it a letter or a calculation. I could pass it A plus, I could add, I could go through it on a for loop, passing variables. I could pass it A plus 1, I think would be a B. It just depends on how it handles those values. Passing by position. Okay. So I covered pass by position, pass by name. If you're in doubt which one to do, pass by position. I think that's the easier one for me to understand. If you like it the other way, do it the other way. Try it both ways. See which one you like. It really doesn't matter. Questions? Functions. The example I use for a function is the mathematics function f of x equals 3x plus 7. Everybody know what I'm talking about. I'm not going to try to teach algebra here. That is a function that would be found somewhere in probably towards the end of elementary algebra, towards the beginning of intermediate algebra. Okay. It's a function, y equals 3x plus 7. So if I talk about f of 5, what do? You take a 5, you plug it into the function. I go 3 times 5, get 15, plus 7, I get 22. You guys are all looking at me like, you're nuts. Okay. A function returns how many values? 1 value. For each value input, you get 1 unique output. For each value in the domain, you get exactly 1 value in the output. Domain is all real numbers. Not all functions have to be valued on real numbers. Accepting real numbers or giving you back real numbers. I can have a function that takes as input people and maps people to their left shoe. I hope everybody just has one left shoe. The one on your left foot. Okay. But the idea is it returns exactly 1 value. What does a function not do? A function does not change its input parameter. A function only receives input parameters. A function cannot change the value of its parameter. So I don't say f of x is 3x plus 7, and I pass it, I'll say let y be 5, and evaluate f of y. Hey, 22, okay? But then I don't expect y to have changed after that thing executes. So you can a function cannot, what, never, hardly ever. A function should not change its parameters. Now you C programmers are sitting there going, ha, 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 ha. I know they can. And it's true. In C, people are, and in Java also, the programmers are just notorious for writing functions that return some kind of a value and they change their parameters. Yeah, they can do it. In C, I can pass a parameter as an input-output, as a pass by reference. I can pass it to a function by reference. If the function changes that parameter, it's changed. Yep. That's bad. If you were in my class, you wouldn't do that. Okay. But C programmers do it. C programmers do lots of weird stuff. I think you're well aware. We don't do it because we can't pass an output parameter to a function. A function returns one value. A function typically, usually does not print, because a function, when I evaluate the y equals f of x equals 3x plus 7, when I evaluate that, I don't expect it to play me music or print something to the screen. It just calculates the value, and that's all it does. So a function does not print. A function does not update a table. I don't know whether it can or not. Would not surprise me if it could. Nothing about it would really surprise me. Maybe it can, maybe it can't. I don't know. Even if you can, you should not update a table from within a function. We say that when it does that, we say it has a side effect. So I suspect that if you said print inside of a function, it would print to the screen. It's okay to do that if you are just troubleshooting something and you want to try to figure out why it's doing something strange, and you want to look at a value halfway through the calculation and see, well, why is that happening? And when you finish and turn it in, don't have a print inside of a function. So here it is, create or alter function. F, this one, I think these parentheses, does it let me not have parentheses? Okay, these parentheses are required. And on the procedures, they're optional. I think I'm going to use them. I'm going to teach it using them on procedures. You don't have to. They're optional, but I'm going to write my code using the parentheses on procedures because I'm used to it that way. Returns an int, so it's different. We have the returns. So the return value of the function is an integer. Begin, you have to have a return. Return 3 times x plus 7. The begin end here are not optional. Even if there is just one line in there, you do have to have the begin end. Thing that gives me trouble with this language is it's a little bit inconsistent in that it will require begin end some places, and other places it's optional if you just have one line. But,
If you didn't have the begin and end, would you have the red?
yes. I tested that. Okay, to test when I create the function, execute, created the function. Now I can test it here by saying select f of 5, and I get 22. I don't. So that's how you don't say execute a function. You say select the function, or you can say set some variable equals f of 5. I don't know why it's making me put the DBO on there, but I have to put the DBO on there. I've got to do a little bit more research, and I'll get back to you on that. I put a little note there. Wait a minute, you know, note to self: go find out why that's true. Why you have to have DBO on there? Because I was trying to get it to work, and okay. Let's go down here to this one. Okay, what am I doing here? I've got a for loop going here. Notice that. How do you know it's a for loop? Because we don't have that word for in our vocabulary with this language. It's a little tedious. So what do I have to do? I have to set my loop control variable, initialize it manually right in line, test my loop control variable while y is less than 10, begin. I do my printing, so I'm just running through from 0 to 9. And then I have to increment it manually at the end. When I do that, I think this should run. So 0, what do I get? F of 0 is 7, and F of 9 is 34. Well, what was the function? 3x, so 3 times 9 plus 7. 3 times 9 is 27, plus 7 is 34, and the others are right too. Computers don't make mistakes. They do definitely make errors. You don't get errors in integers. As long as you can stay in integers, you're in pretty good shape. Once you start working in anything that's got a pi floating around in it, look out. Okay, okay, let's see what else we got here. I have not written the assignment for, I'm going to write, we're going to write a function. So here's where we're, okay, here's how you use a function. Now, it is considered, let me back up a little bit to the first assignment. In the first assignment, I don't think I made it a absolute point. Did I tell you you had to write the winner back into the database for each one? I don't believe I told you you had to do that. I said we were going to do it on the next one, and then I thought, well, wait a minute, that's kind of a bad thing. So some of you went ahead and did it, and that's okay if you did, that's fine. It is considered in database bad to store any value that you can calculate. I'll say that again. It is considered bad form in a database to store anything that you can calculate. Now, for those of you who remember the AP database, remember that? The AP database has a, let's see, what were, there were 2 tables. We'll go look at that database some more. It had a table, let's see, vendors, and it had another table called invoices. The invoice table had a line called invoice total, and that was stored in the database. The invoice total was the sum of the invoice line items where the of a join of the invoices to the invoice line items on the primary key, foreign key. So it was a sum. So the invoice, what they stored in there was calculated from the invoice line items table. That was very bad because there's nothing checking it. There's nothing that says you can't have a bogus value in there. What if it didn't match? What is it that checks it? So we never store something like that. I never store your age in the database. I store your date of birth. If I have your date of birth, I don't want your age in my database. I have your date of birth, I'll just calculate it from that. I can calculate your age. And when you have a birthday, it's going to change immediately. You can. You can.
Calculations.
Well, I can use, we're going to talk about how we can use referential integrity, that buzzword there. We can enforce that other ways than a table constraint.
Well, maybe I should use the phrase foreign key. Because, I can see where
Mhm.
it would be advantageous to have a calculated
Right.
value in there, because at a glance, you could just, when you're
Okay, the way we're going to get that is with a view. And we're going to talk about that. So you're going to look at it, you're going to see it as if it is in the table, but when you, where does it really come from? It comes from the calculation. Okay, for example, let's look at this, this one that does the digit. Now, my function is digit function, and it returns a char, and it just does the usual stuff. Oh, one other point about a function. I cannot throw an exception from within a function or a procedure from within a function. I cannot throw an exception from within a function. That breaks the idea of the function. So if I get a bad value, I just return null. That's how you tell when it comes back null, that means you had bad input. Otherwise, I just go down through it in the usual manner. And then at the end, I return the digit. So here is this is an example of a local variable. I declare a variable inside of my function, give it a name. It exists only in this function. I can't see it from outside the function, and it's my little scratch paper I can use inside the function. So here it is, and as I go down through here, I set that local variable to either 2, 3, 4, 5, 6, 7, 8, 9, and then I return that value. Now it goes away. Here I'm testing it. This is a test. Okay, this is where the rubber meets the road on the phone. Now, I'm going to execute this all the way through this, right? Insert into the telephone all of these values. Now, inside of this select, look at this select statement right there. This is the power of it. I write one select statement, and the select statement selects the CH. Here, it executes the function, gives you back that value as digit from the telephone. So when I execute this, oops. So, okay, I guess I have to execute the whole thing, don't I? Anyway, there it is. I hadn't executed the create function. Notice that I don't know whether you can, I don't think I can roll this up any. I think I'm stuck with that font. But notice that A is 2. Notice that this column right here, the ones where null weren't valid values. So for example, the tilde wasn't valid, the Q wasn't valid, and the Z wasn't valid. Rest of them were valid. But what did I do? I never executed the function. I never had a cursor loop executing the function. And then comes the second major rule of programming. We don't use cursors. Avoid a cursor every chance you get. Always try to avoid a cursor. If there's any other way to do it, don't iterate through the table with a cursor applying a function. Write it as a function and then simply just execute it in your select, because I can execute a a function inside as I can select the value of a function, feeding it from a table. And the thing of it, here's the real power, is right here. And all I have to do, I don't have any variables or anything. I just go in there and I execute that. I just execute it again, and I have the values. If the table changes, make him a J. Well, I'd write an update. I'd have to update him. I just don't feel like fooling with it. If I updated the table, ran it again, the function would give me the correct values. Okay. Now, here's where it really gets powerful. And what time am I? 7:44. I might have time to finish this off. I'm going to talk a little bit about views. I have put a new module into our course online, and I'm kind of writing it as we go. I'm about a week ahead of you. So I put a module in there on views. Now, a database view is, how many of you have taken Access? Oh, I'm sorry. I'm so sorry. Yeah, ITSW 1307. Now, it's not that I'm not griping about Access. I'm not going to knock Access. Access is perfectly good language. It's just people use it. We tend to teach the class about Access instead of about database. But in Access, when you create a query, you save the query. When you guys did your 1307 class, ITSW 1307, did you ever touch SQL? Okay, SQL's in there. You can get to it in Access just fine. It's kind of a strange dialect, but it's there, and you can write SQL. And if you can you could write your tables, and if you moved your tables from here to all your SQL that you wrote on the AP database will run just fine, most of it. All your table joins are going to work just fine. Your primary keys are all the same, not null constraints, all the same. And it should just run, everything should run the same because it's an SQL-based platform. But when you write a query, you don't actually write the query and execute the query. You write the query and you save it, okay? And then you can execute it anytime you want to. That's not a query. That's a view, okay? Now, I'm not going to sit here and get in a big argument over what is it, a query or a view. They call it a query. They want to call it a query. That's fine. I call that a view. A view is an SQL statement that is saved in your database, and it looks to you just like a table. It acts just like a table. You can select from it just like a table, but it's really an SQL statement. Okay, and you can join it. You can do anything with it. Now, it's the same thing as one of the places that people had a lot of trouble in ITSE 1309 was when we did subqueries. Remember doing subqueries? Do you remember doing derived tables? Derived tables where we defined a query in the from line, and we put a query in there. We selected it from a query. That was a view. That was an anonymous view. That's all it was. So I almost never do that, by the way. I just create a view and then drop the view when I'm done with it, because a view is cheap. The view itself is cheap. You pay a little bit more at runtime with a view, but creating a view is nothing because you don't duplicate any data. When you create a view, first thing you have to remember about a view, I'm going to create something. So what do I have to do? Bracket it with goes. Anytime you see that word create, think I need a go in front of it, a go right after it, nothing else inside of that go block. That's true with creating tables too, although our book doesn't do that. It should. Okay. Go. What shall I call this? How about teleview? Good as any. As. Okay. Okay. Well, I didn't this time. It wouldn't be a bad idea. You have lots of different things at lots of different levels in this programming language. Anything you can do, if you want to put VW in front of it, prepend VW, that's fine. So he's suggesting VW, meaning identifying it as a view. Yeah, it's not required. So I'm not going to lay a bunch of stuff on you about, you're not following my convention. There's so many little things that we're naming here, and they're not, all they're going to do is multiply. They're going to exponentiate. So we're going to have levels, and then when we get to forms, then you'll have variables in the forms and variables that come from the database, and it can really get wild. So it's best if you have some kind of a naming convention that tells you what stuff is and follow it. And it's your convention, because the person that's going to probably have to fix this is you after you've slept.
So when you talked about an anonymous view in that drive table,
Yeah.
the reason it was anonymous is
Right. Well, we gave it a name, and there we had to give it an as. So when we had a derived table, we had to name it. So actually, it's a temporary view. Yeah, it was created and it existed just for a moment, took stuff out of there, and went away. Go ahead.
Are views in a separate place in the object cluster?
I'm sorry. Ask that again. Our views what?
Are views in a separate place in the object cluster?
Yes. Yes. You have tables and views, and let's see if I can find it. That question was, are they in a different place in the object? Let's go to databases, and I think, let's see. I haven't created this one yet. They're right under tables. You have your views. Everything's in the object browser. There's nothing wrong with a GUI, nothing wrong with a graphical user interface. I'll never knock one, but this is a class about programming, so we're not gonna program over there. Okay, it's time to create the view. So the view is created inside of its own Go block. It begins with a Go and it ends with a Go, or it can be the only thing executed. It'll be fine. I can just execute this right here. I don't need anything else, and it is successful. Now that view exists, and I think actually that's going to be over here, and I think he's going to create it in SW Smith. Nope. Okay. Well, every time I VW Teleview right there. Okay. Now I can execute it, and I can select. All I have to do is say select everything from VW. Okay, and this will execute, so I don't have to have any kind of a loop. I didn't have to open a cursor, and that's the power of a function, is that it can just go right into the SQL code, and I want to avoid a cursor like the plague. because a cursor is going to slow your code down. It's just an SQL platform is optimized for running SQL, not for opening cursors. Opening a cursor will typically run about twice as long as the corresponding SQL. So the best way to do this is from a function. Okay. So basically, what I'm going to do when I type it up here, the second piece of the assignment on this module is going to be create a function. I guess we usually have to agree on the name of the function, so I'll tell you what to name it. I usually name it winner. It takes 2 character variables, play 1 and a play 2, and it returns either a 1, a 2, or a t, a character value 1, the character value 2, or the character value t. And so from this, now you don't store those guys you just run an SQL statement and it comes back, and then you can create a view and you can say, now go in and count the number where you say return count where it's a 1, count where it's a 2, and that'll tell me the winner of the overall game. So life gets fairly, you have to run. Okay. I'm about to wrap up here anyway. We're going to talk more about functions. I know it's getting to be that time where I said I will wrap up at 7:50, and now it's 7:55. So I'm going to wrap up and move to lab. I am going to go back into functions. I'm going to talk more about functions because, in my opinion, functions are more important than the procedures, although procedures are nice. Procedures, I can change the parameters. So you think of procedures as doing something for me. A function returns 1 value. A function is nice and clean and hopefully fairly short and simple. And then as I put my functions together, I finally have a overall procedure that, might I call it main, that runs everything. Okay. Any question? By the way, functions can be called, functions are almost always passed by position. Parameters are almost always passed by position. I believe that they can be passed by name also there. I'm a believer in passing by position. But I'm not going to insist that you be one also. Okay, we're going to wrap up there. Let me see how my internet people are doing. Let's see, anybody out here in internet land that's still awake? Let's see.
Yes.
Okay. I'm about to wrap up and shut this down. Any questions?
No, I'm good.
Okay. Wayne? Okay, and Donna's here. Okay, I'm going to end the recording now. Okay, recording is ending now.